So am I live right now? That's the question. It seems to be that I am live. I should check. Yep, I am live right now. Yep, it's working. Yep, I am. So, is there something wrong with my setup? No. So let's just dive right into it. I will be focused on some projects and competitive programming through this thingy. Okay, so let's do an easy problem first. I have switched to Arch Linux recently, so that's new. So there shouldn't be any. If there is live chat, I should see the live replay. Yep, it is open right there. So yeah, so there are integers in the range from 1 to n, and among all pairs of distinct integers in this range, we have to find the maximum possible greatest common divisor of integers in pair. Formally find the maximum of GCD, where is an integer. Okay, so it can contain n integers, and then we have to, for only contains a single integer n. Okay, the first line is a single integer t, the number of test cases. The description of the test cases follows. So 1, 2, 3, 4, 5, 6. So we have to go from the range 1 to n and find the common divisor. So let's see. What's the common divisor of 1, 2, and 3? I'm going to connect scalar draw. So what's the common divisor of 1, 2, and 3, right? So 1, 2, and 3. What is the common divisor of them? It would be 1. What about 1, 2, 3, 6? It's also going to be 1, if I'm correct. So in the case of 5, 1, 2, 3, 4, 5, the common divisor of this is 2. The common divisor is this. Actually, I don't understand. Oh, yep. So in the first is a GCD of 1 to 2 is equal to GCD of 2 to 3 is equal to GCD of 1 and 3. So in the second, we have to print out the maximum possible value. That's why. So let's say the maximum GCD would be, actually, if it's even, like say something like, let's say 12, the maximum GCD should be 6, 2. Yep, right? Like it should be GCD of 2 and 6. Like it's 2 and 4. The GCD of 2 and 6 or 6 and 12. Something like that. So it'll give us 6 as the answer. And if that's the same as 13 goes, so the greatest common divisor of 1 and 13 is 13, but 1 and 12 is also 6. So if it's an odd or even, it should be something like that. I'm not sure, but I could give it a try. So let's actually see what we can do. So if n is even, then we're gonna do that, and else we're gonna n minus 1 divided by 2, then n line. But I don't need that, so we can just see, and it's giving us 1 and 2. So For what I think, that should just be the answer, but we actually don't know what the answer can be. So as it's not a contest anyway, I'll probably get a wrong answer in test 2 or something. But let's see. And it's accepted, and what I thought was right. So we can go to the next problem. So the problem should be, I'm gonna start off with some easy problems, and then we can go to harder and harder problems. So yeah, I'll complete all of the easy problems, right? So in a single row. Insomnia Cures, I don't know, like the brute force games. Like there is just way too many talkings right here, right? So like I don't know, like that stuff. So let's go to Daryl. So Yakko, Wakko, and Dot, world famous maniacs, decided to rest from acting in cartoons and take a leave to travel a bit. Yakko dreamed to go to Pennsylvania, his motherland and the motherland of his ancestors. Wakko thought about Tasmania and its beaches, sun, and sea, and Dot chose Transylvania as the most mysterious and predictable place. But to their great regret, the leave turned out to be very short, so it will be enough to visit one of the three above places. That's why Yakko, as the cleverest, came up with a truly genius idea. Let each of the three roll an ordinary six-sided die. Okay. So, and the one with the highest amount of points will win, and will take the other two to the place of his/her dreams. Okay. So Yakko thrown a die and got Y points, Wakko W points, and it's Dot turns, but she didn't hurry. Dot wanted to know for sure what were her chances to visit Transylvania. It is known that Yakko and Wakko are true gentlemen, and that's why if they have the same amount of dots, same amount of points with Dot, they will let Dot win. So the output, the required probability, the form of irreducible fraction. A, so where A, the numerator, and B, the denominator, if required probability equals to 0. Output 1 by 0, 0 by 1. So it's a cool problem. So Dot will go to Transylvania if she's lucky to roll 4, 5, or 6. So basically we have two integers, right? We have one at the top, we have the numerator and the denominator, okay, the denominator. So let's see, she has 6 chances to be right. So 1, 2, 3, 4, 5, 6 to get the highest amount of points. So in the max, they have to go, so they have 4, 5, and 6. So let's see, 4, 5, and 6. So that's how many chances they have. It is kind of interesting. So let's see. What if it was 1 and 2? 1 and 2. So it's gonna be the lowest, the highest one. That's 2 by 6. Or we can say 1 by 3. So it has to be an irreducible fraction format. So how to convert decimal to fraction in C++? Is there any function converting a floating point? That's wait. How do you convert a decimal to a fraction? So if if in this case first we take the integer a and b, and we're gonna take the integers input. So if b is divided by a, if to 0, that means they are divisible by something. Like what about 93 or something? Like, because it's just 6 integers, there can be something like 2 4 and 2 6. So if it's divisible, then we will of course do something about it. It's not gonna be 6 and 8, and it's not gonna be 2 and 8, because something like 5. Okay, so 5 is a prime. So yep, what I'm thinking is if it is done, then we're gonna set then it's gonna be a is equal to 1. First of all, we're gonna say b is equal to b divides equal to a, and a would be equal to 1, and else see what b with in what format is it? Okay, so it's b divided by with the divide symbol, and then it's gonna be a with an line, of course. So yep, so yep, as it's like that, so we can do that, and it's 2 by 4, which it shouldn't be. Our aim mod b equals 0. Who cares, brother? It's the same thing. I don't want to do any extra operations. Shouldn't be 1 by 0. Max of b and a should be divided equal to minimum of b and a. Measure x is equal to max of a and b. So x divide equals to minimum of a and b. So, and what I did is would be x followed by a, or a followed by x. So according to my calculations, it should be 1 2, it should be not a half. That's actually not the answer, because it would be 2 by 6. Okay. If one of them is a, this would not be the answer, right? So there should be another answer for this, which I have no idea about. So let's think about this one. So it requires the probability equals to 0, so you have to also say that. But if it's 1, it will be divisible, because one of them will be divisible, right? So we have to go with the max. If max of a and b is greater than minimum of a and b, so 1 and 2, it's still giving me 1 and 2, so So the max is 2 will be always divided by 1, so z is equal to minimum of a and b. And z is greater than 1, because if it is 1, we won't be doing this. So 1 2, it's still giving me 1 2, and I have no fucking idea why. So I'll be going through the editorial of this because I am tired too. So if a maximum of access point is, if maximum of access point is a, then dot will win. If you live since there are only 6 values, you can simply hardcore. You can simply hardcore the answers. So 6 minus a minus 1. So integer y and w, so we're gonna take them as inputs. So then we are gonna take them as inputs. After that we will say the probability of our win is that. So if she has not less than a point, so the probability of our win is 6 minus, the answer is equal to 6 minus a minus 1. If integer answer is equal to this, and integer a is equal to maximum of y and w. So if 6 is divisible by answer, then we're going to set answer is equal to 1, and see out 1, and it will be answer divided by 6. Or should I say 6 divided by answer? And return it, and so we'll see out answer followed by 6. 4 and 2, 1 and 2, 3 and 4. So the maximum only matters, right? So it's a 2 and 3, and that's 4 and 6, right? And we can say again, if answer mod 2 double equals to 0, then we're gonna do answer times 2. As there are only 6, so it shouldn't be a problem. Return in line, of course. No, then in line, of course. Okay. So 2 and 3, 3 and 4, 5 and 6. Okay. We can submit our solution here, right? So yep. If there were more than that, we gotta worry about 5 and 6 and a lot of stuff. and right now it shouldn't be yep, it's accepted. The memory isn't good, but it's accepted. Yeah, so let's go to the short substrings. I love problem with substrings, so I hope it will be better. Okay, so Alice guesses the strings that Bob made for her. At first, Bob came up with a secret string A consisting of lowercase English letters. The string A has a length of 2 or more characters. Then, from the A string, he builds a new string B and offers Alice the string B so that she can guess A. Bob builds B from A as follows. He writes all the substrings of length 2 of the string A in order from left to right. Then he joins them in the same order into string B. For example, if Bob came up with ABAC, then all the substrings AB, BA, AC. So therefore the string B would be AB, BAC. Okay, so all elements that are equal to 1, then we increase I. Okay, you are given the string P and it can be proved that the answer to the problem is unique. So A, B, B, A, C, so it's gonna be A, B, A, C. A, C, it's still gonna be A, C, A, B, C, D, A, if. Okay, so it looks like a pretty easy answer. So then we're gonna have ourselves a string S, C in S for integer I 0 to 0, I 0 then and I plus plus and with that size. Okay. So if A of I double equals A of I plus 1. So first was a string B is equal to P dot push back S of I. It's gonna be S and it's gonna be S. Okay. So if they are equal, then we're gonna be like I plus plus. And we have to see out B with an N line. And I hope it'll work, so let's just do it in one fell swoop. And it's ABAC, ACBC. Yep, wait a second. It should be 5 Z's here. And there is more than 5 Z's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So even if it's equal, there could be an issue. That is, so only in the even cases do we do that. And I mods to w equals to 0. So it's and it's either even or it's gonna be odd. Yeah, now it is giving me 6. So it's working, and so we are gonna submit it right around here, and we're gonna submit it. So it should probably, if I get a wrong test on, like a wrong, yep, it's accepted. So yep, it's fine. So 197 problems have been solved. I have 3 problems left to solve. So let's just going through these problems. So even array. So you're given an array of n integers You are given an array that consists of 0 to n minus 1 of length n, which consists of non-negative integers. Note that the array indices start from 0. Yep. An array is called if the parity of each index matches the parity of the element at that index. More formally, an array is good if for all I, the equality of I mod 2 is equal to I mod 2, where x mod 2 is the remainder of dividing x by 2. Okay. For example, there is 0, 5, 2, 1, and the 0s and 0 are good, but the array 2, 4, 6, 7, like 2, 0 element is good, but for the 1 it is bad. Because for I is equal to 1, the parity is I on I mod 2 is I mod 2 if I is equal to 1. So you have note that the array indices start from 0. Okay, so we have to use 1 in this case, right? So, but if I mod 2 is equal to 4, okay, 2 and mod 2 and 1, if I mod 2 is equal to 1 mod 2 is equal to 1. So the first I should be calculated as 1, and for the second of I mod 2 is equal to 4 mod 2. So let's see. Okay, so it starts at 0. So in MapMove, you can take any two elements of the array and swap them. These elements are not necessarily adjacent. Find the minimum number of moves in which you can make the array good, or say that it is not possible. So let's see if we have two. They are of distinct integers, right? Every 3276, 326. So yep, they are of 0 to n minus 1. So they are distinct integers. And it's called good. So you can array of 0 to n minus 1. So it can contain 0 and n minus 1. So we can just say if the parity doesn't match and the next parity does match, then we would need 1, else we would need 2. So in this case, the parity of this is 0, so it's on the 0 is always going to match, right? Or we can just, we have to set the odds to odds and evens to even. So like there can just be with odds, right? Then it's impossible. The number of odds and evens should be equal, right? If it isn't equal, if it isn't equal, then there's no way we can actually manage it. And if this is possible, the answer would be the farthest parity there is. Okay, so it's a bit tricky, so I'll be seeing the tutorial. So we will split all the positions in which parity of windows does not match with the parity of the so we split all the positions in which the parity of the index does not match with the parity of the element into arrays. If there is an odd number in the even index, add this index to the array E. Otherwise, if there is an even number in the odd index, add this index to the O array. Note that if the sizes of the O and E array are not equal, then there is no otherwise the array can be made good by doing exactly O operations by simply swapping all the elements in the O and E arrays. Okay, so quite an easy problem. I've never thought about it. So integer A and B, integer N, C and N, so it's going to be equal to 0, and it's going to be equal to 0. and we are creating a vector integer a x with the size of n, not fx, let's call it m, vec m. So we're gonna go rep I with n. So if the parity is not matching, if I mod 2 not equals to a of I mod 2, then we're gonna m of I mod 2 once a plus plus if actually I need to check one thing. What should we check actually? Like the parity or what? So if it's not, okay, what I did was right else b plus plus. So if a not equals b, c out -1 with an line, else c out a with an end line. Okay, so it's gonna be so it's gonna be 0 and not that many -1s. So I have done something wrong, extremely wrong. So we take the inputs, and if that and the ith integer, well, it should be the answer, right? So if I mod 2 double equal not equals to m of I mods 2, then what do? We said we first do a plus plus, so we do b plus plus. And if a of I not equals to b of I, so let's say c out a b. Of course, 0 3 4 0 2 1 1 0 0 7. That's what I'm saying is right. So if I mods 2 double equals to 0, a plus plus, else b plus plus. And that is collectively the answer. Okay, so it was interesting, not gonna lie, it was pretty interesting. So let's submit our problem, and 200 to 200 we have 2 more problems to solve, and then we will be good to go. So let's see if yeah, my stream is doing pretty good. I can listen to myself. So now let's see what we can do. So we have a couple of more problems to solve, so we can definitely try solving some more problems, 2 more problems, and I will end the stream, and I could do some project later on tonight. So let's see the bars. It seems good enough to solve, and 62,000 or 64,000 people can solve it. I also I can. So ternary numeric notation is quite popular in Berlin. To telegraph the ternary number, the Bohr's alphabet is used. Digit 0 is that, digit 1 is that, and 2 is that. You have to decode the Bohr's code. So we have to decode it. So first we take the string, then what we can do is, so there are two types of answers to this, right? So if after the dot there is something, so post dot there should be, we're gonna the string answer to be this. So what we're gonna do is, for integer I is equal to 0, I is less than s dot size, and then we're gonna go I plus plus, and then we're gonna do something like, so if s of I double equals to the only symbol mod. So if it is dot, then we do not do anything. We actually just put answer dot push back is equal to 0. Answer dot push back, it's gonna be 0, and else if s of I double equals to dash. So this one's interesting. So first we're gonna do is I plus e pi, or we increase I by 1, so we do not want the other one to receive. So if s of I plus 1, actually it's gonna be s of I plus 1 equals to this, then we are gonna say like answer dot push back 2, else answer dot push back is equal to 1, plus plus, and it's gonna be, we're gonna see out the s with an n line, and it'll have nothing like, so no test cases. Okay, so we are gonna, and it should, that's my mistake, yes, so we are not, so it should be this. Okay, so my carpal tunnel is hitting me. So let's see what we can do. So yep, 0 and 2, that is our answer to the problem, and we can also try 2 0, that is also the answer to the problem. And yep, so the solutions do match. So we can submit this one, and we can, yeah, we can submit this one. So yep, it is accepted. So we have probably have one more problem before we hit 200. Yeah, one more problem. So we can go with a bit of a harder problem, because I'm just getting warmed up for tomorrow because it'll probably be a contest tomorrow, so I wanna warm up my skills. So something of a harder problem, and here I'll just filter to 1000 to 1200 level problem and go with a greedy problem or a dynamic programming problem. This one looks good, but let's see. Okay, let's see this one. Okay, so let's call an array A beautiful if you can make all elements the same by using the following operation an arbitrary number of times, possibly 0. So we can choose an index such that the previous index equals to the next index and replace the index with its previous index. So you are given a beautiful array A of A to N. What is the minimum number of elements you have to remove from it in order for it to stop being beautiful? From swapping elements is prohibited, so it is impossible to do so. So if it is impossible to do so, we can so let's kind of, if you can make its all its elements the same by using the arbitrary the following operation arbitrary number of times. So brute forcing would be a good option, but we also have enough time though, and the how many, so n can be quite large, but we also have enough time. So brute forcing would be an solution to this, but let's see. So we can change if the next and the previous element is equal, then we can replace the current element with its previous element. So yep, additional constraints are in every case the given array A is beautiful. The sum and so additional constraints on the inputs. In every test case, the given array is A is beautiful. So like for like this. So 1 2 1. So the previous element on the next element. So the first element doesn't count, and the last element, the last one probably doesn't count. So we can say 1 2 1 2 1 2 1. So if the previous element and it's so we can change it to 1. So that means 3 elements will become the same in an instant. Yep. And from them we can go to the next one. So all the so in this case, so this and this is equal, so we can change this to that. So why would we, in the fourth you can remove for the first 3 elements. For example, the resulting array 533 is not beautiful. So we are given what is the minimum numbers you have to remove it from in order to stop it beautiful. Also we have to make it not beautiful, right? So if all the elements are same, that is not possible to do so, because there wouldn't be any elements left. So we are given an array of A to N. What is the minimum number of elements you have to remove it on in order? So what is the minimum number? So we can choose an index such that you replace A of I with A of I minus 1. So in the resulting array, so the resulting array will be 1 2 1 2. Let's check if it is equal to operations of array which is I is equal to 2. The array becomes 1 1 and 2. So no more operations can be applied to it. Then the number of elements are not the same. Then the numbers of elements, the number and the numbers are not all the same. Choose I is equal to 3. and the array becomes 1 2 2. So no more operations can be applied to either. The numbers are still not all the same. So let's go now if you can make the if you can make all its elements same by using the formula of a given formula. So we need how many operations we can use to make it not beautiful. So if an element is at the very first, like the element which is or we can also say that if two different elements are one integer apart, it won't be this the array won't be beautiful. So let's get back to the problem. So let's see what we can do. So let's see, we have a of 1. So let's say 1 2 1. We can make this equal, we can make this like beautiful, because we just take this and replace it with this, so we would have 1 1 1. So it is doable. So what if we had 1 2 and 3? Or let's just say 1 2 1 2 1. So if we select this, we would have 1 1 1 2 1. So then we can select this and it's still doable, I guess. 1 2 1 2 1 1 2 1 2. So it is doable. Yep. So we can loop through the integers, and if something is not equal to it and the next integer is equal to it, then we will remove all of those integers, right? So just setting something at the very beginning will be an integer, and a of I could be actually pretty big, right? Any integer from the very beginning can be an answer. And we have to find the maximum or we have to find the minimum number of elements. So it would be the minimum number of elements which the first odd element, I guess. So 1 2 1, we can remove one element from here. 1 2. So we take the first element, and if it continues, and like say 1 2 1 2, let's actually go something like this. So let's see, 4 5 6. It's the array should be already beautiful. Like the array, if the given array is already beautiful, that means every integer in the same parity should be the same, right? So the first integer that is not the first integer that is not the first integer, if you know what I'm meaning, so that would be the answer. So okay, so in this case, if there is just no more answers, then it is not possible, and the first non-first answer should be the answer. Okay, so let's see, let's do something like so first integer n, then we're gonna take our input, then we create our vector with the size of n, then we are gonna take that as an input, and then we're gonna go through the vector, and integer answer is equal to 0, and integer check is equal to a of 0. if a of I not equals to a of 0, so we're gonna go break. Okay, for jar is equal to 0, I plus plus, so 1 to 2, so yeah, so for the 0th case it won't work, but for it would work. So I is less than n, I plus plus, and it should be set to 1, or we can set to 0. Both cases work. Oh no, we have to set it to 1. That's a plus plus. And we're gonna see how it runs with an n line. If answer double equals to 0, then we're gonna go and see out -1 with an n line, and we're gonna return. And we have to also set the input lines correct. So I don't know if this will work or not, but we can give this a 1. It's gonna be, if the first one shouldn't be possible. So if it is equal to 0, or if it is equal to, if answer is equal to 0, or answer is equal to n minus 1. -1, yep. So -1, 1, -1, 3. So I have no idea if it will work or not, but it should work if I'm doing things correctly. It has a high possibility to not work, and it's probably not gonna work, and I don't know why it's still running on test 1 and we have a wrong answer on test 2. So we are in for a long run. So let's just refresh our page, and Codeforces is glitching out pretty much. Why is Codeforces glitching out so much? I have no idea. So it's been 53 minutes and we have wrong answer on test case 2, and this is probably wrong answer on the 14th number. So expected 1 and found 2. So I'll be going for the solution on that one. So it was make it uglier. So as given in the problem statement, the definition of a beautiful array is not very interesting, since checking the beauty of an array is quite complex. Let's try to simplify. First off, all the first and last elements will never be changed, as it is impossible to choose such I for operations. If they are different, then the array is definitely not beautiful. Moreover, the array is beautiful, then all its element at the end will be equal to the first and last element. So the second idea is a bit more complicated. So notice that each element, okay, so we won't go for the complicated one. So last is -1 and answer is equal to n. So we go through the array, and if the a of I is not equal to the first, then we set it to the last again. So the first of all, the first and ideal last elements will never be the chains, as it is impossible to choose such elements I for operations if they are different. Then the array is definitely not beautiful. Moreover, if the array is then all its element at the end will be equal to the first element. So that's a point. Like, we can also remove the last three integers. So let's see. If there were two integers here, then there would be. Okay, so let's try that. Answer to 0. Integer answer 2 is equal to. So yeah, when we get that, we set it to that, but we have to get also our I value, right? So let's see, for the case it's going and it's starting from the second value, then that second, and that. So it's on the third value, and we should get I is equal to 3 for that value, right? Even if it's the fourth value, we get I is equal to 3. And then with the value we get, we minus 1 from the array. So we say so integer temp is equal to I. So the final I, we'll get it from here, and we're gonna go cout and minimum of answer and temp minus n minus temp minus I with an n line. Integer temp, and yeah, fi, and it should be 1. So if we can check the element, if we check my submissions, actually let's try and submit this one, I guess. And this one can also work. This one can pretty much work, except it won't probably again. So -1 1, -1 and 3, and so we can also remove elements from the last, I guess, and we will get the same error again. Probably yes, but yep, we got ourselves our error. So I'll be figuring that out. Not right now. Probably my Chrome is again glitching. So it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ah, shit. It's gonna be our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one, I guess. So and it's giving us 2, and it should give us 1. How so? So if we, yep, that's what I'm saying. So we get 2 elements at the very beginning, but there's 1 element in the last, and that is way easier. So how we are going is, we have the first index and we go to the second index. So yep, it is matching. So we save the second index, so our temporary string I is equal to 2, and then we minus from n minus I minus 1. So it shouldn't be that. So n minus temp minus 1, 0 n minus temp minus 1 with an line. Let's see the v, and so it's giving me 1. It's giving me 1 now. It wasn't giving me 1 before. And my answer in the long end was right. So we can just be like, we can submit it again. So actually we didn't need the editorial anyways, if it's now. And we still get an error again, bruh. Just work now. I don't know why. I have no idea why it's, yep, just load right when I was refreshing. Load just right that second. What's this? I don't know what's that. So I will be checking out what's the issue. So it's the 189th number. So there is some sort of point I am missing, and I have no idea what that might be, but I am missing some point that I should not be missing. So I'll be ending the stream right now. It was a good stream. I might stream about you didn't change the code, that's why you're having error. I did change the code. It was the 14th test case before, and now it's probably the 190th test case. So I am missing a perspective on the problem, and I'm gonna take a break. So I'll be ending the live stream right now. So that's it, I guess.